We will see a few chemical properties of carbonyl compounds, mainly aldehydes and ketones. Chemical properties or reactions of carbonyl compounds. Mainly aldehydes and ketones. Since ketone contains or aldehyde contains a carbon-oxygen double bond, so there is a polarity between the carbon and the oxygen. Carbon has partial positive charge and oxygen has partial negative charge. As a result, if any reagent having positive and negative charge comes nearby, then they undergo addition on this carbon and oxygen with opposite charges. Like hydrogen will try to get added to oxygen and cyanide will try to get added to carbon having partial positive charge. As a result, it will form a carbon, oxygen, 1H and Cn. Now, if this would have been aldehyde, then it would have been like this RH. If this would have been a ketone, then you would have written it RCOH, another alkyl group CR dash and Cn. So system is carbon oxygen double bond. Okay, this is carbonyl group. Carbonyl group. If we understand the concept of carbonyl group, then individually we don't have to study ketones and aldehydes, because all the reactions of ketones and aldehydes are mainly due to the presence of this carbonyl group, which is common to all carbonyl group compounds like aldehydes, ketones, carboxylic acids, acid anhydrides, and esters. Second, this carbon oxygen bond can undergo addition reaction with sodium bisulfate also, or sodium bisulfite also. Example, if it reacts with NaHSO3 minus, so just like the previous reaction, sodium will go here and bisulfite will come here. So it will form oxygen O minus Na plus, and this will form O S O O minus Na plus, and the hydrogen part will come over here, or it will remain in equilibrium. It will remain in equilibrium with the H plus ion. because both Na plus and H plus are replaceable, ionizable, so they can be in equilibrium. So it forms an adduct, isn't it? Addition product. Its name is cyanohydrine, and these are also adduct. Adduct means addition product or product of addition reaction. We will see some more reactions now. Chemical reactions or properties of aldehydes and ketones. We will see third reaction. If say an aldehyde RCOH reacts with any alcohol R dash OH in presence of HCl as catalyst, then it has two parts. One part is positive, this H plus part is positive, and OR minus part is negative. So HCl will polarize this carbonyl compound, and after it gets polarized, then H plus will go and add here, and RO minus or R dash O minus will go and add here. So it will form hemiacetal. OH, O R dash, and H was already there. So this OR and this H has come from this H and this OR. Reaction number 4. If any ketone, say R, carbon double bond oxygen R dash, if any ketone reacts with ethylene glycol, CH2, CH2 ethylene glycol, that means 2H. Then what reaction takes place? Although it is not mechanism, but for understanding we can draw it like this. This H2O will come out, minus H2O will come out. From here minus H2O will come out, and it will form kettle are carbon R dash O O CH2 CH2 and O. It is called as kettle or ethylene glycol kettle. It is a kettle and it is ethylene glycol. So together we can call this as ethylene glycol kettle. Ethylene glycol kettle. Together we can say it ethylene glycol kettle. We'll see some more reactions now. Chemical reactions and properties. Chemical properties of aldehydes and ketones. What happens when it reacts with any amine containing group? Say for example hydroxylamine. Say R, if this kind of system is there and either NH2 is there, and if I write Z, this could be OH or this could be alkylamine, whatever. So this Z could be anything. So what happens? Again, just to remember this, we can take out H2O, one oxygen from here and two hydrogen from here. H2O will come out and it will form hydrazone. It will form hydrazone. R, carbon, R dash, double bond, N, and whatever was there. If OH is there, then OH will be there. If R is there, R will be there. So we can write Z. The system which we have to see is carbon oxygen double bond is one system and NH2 is one system. Now this could be hydroxylamine, or it could be alkylamine, or it could be even hydrazine, NH2, NH2. It is hydrazine. So since it is ketone and it is a kind of a hydrazine derivative, so this kind of molecule we'll call as hydrazone or substituted hydrazone. Ketone and hydrazine forming hydrazone. Then we will see how to reduce carbonyl compounds. When I say carbonyl compounds, I mean it can be aldehyde or it can be a ketone. In case of ketone, the carbonyl group is flanked with two alkyl groups, and in aldehyde, the carbonyl group is flanked with one alkyl group one side and another hydrogen on the other side. So, if you give reducing agent like hydrogen adsorbed in a nickel or runny nickel or platinum or palladium. These are catalysts which holds nitrogen by adsorbing it on it, or by giving lithium aluminum hydride, or by giving sodium borohydride. It will form ROH H and the two hydrogens are added. One hydrogen is added here, one hydrogen is added here. One hydrogen is added here, one hydrogen is added here. Similarly, so this will form primary alcohol. Aldehydes will form primary alcohol, and ketones will form secondary alcohol or even tertiary alcohol. If you give hydrogen adsorbed on nickel or platinum or palladium as catalyst, or you use lithium aluminum hydride, or you use sodium borohydride, then this will form RCOH H and R dash. It forms a secondary alcohol. Now, if you want to reverse this reaction, you have to give oxidizing agent. So the same reaction can be reversed also. If you give oxidizing agent to this, it will form aldehyde. What could be the oxidizing agent? KMnO4 in presence of base, or K2Cr2O7. This can also be reversed if you give KMnO4 in presence of base, or if you give K2Cr2O7 in acidic medium. These two are oxidizing agents, K2Cr2O7 potassium dichromate. This we are studying in the D block elements. Okay. Now, why don't we use zinc, Hg, and HCl? It gives lots of hydrogen gas, and with lots of hydrogen gas, what will happen is it will lead to complete reduction, and then alcohol will not be formed. Corresponding alkane will be formed. Okay. So this was partial reduction. Here, the reduction which is taking place is partial reduction. Because there is some more scope. Yet there is some more scope for reducing this oxygen also. Even this oxygen can also be reduced. Okay, so we'll see how it can be reduced. Complete reduction of carbonyl compounds. There are two ways in which it can be done. Means two common ways. There can be many ways, but there are two common ways, which involves name reaction, so it requires special attention. One is clemmenson reduction, and the other is Wolff-Kishner reduction. In clemmenson reduction, whatever the carbonyl group is there, R, carbon oxygen, H, is treated with amalgamated zinc. Zinc amalgamated with mercury and HCl. So this leads to slow release of H2 gas. Okay, amalgamated zinc leads to slow release of H2 gas, and slowly it forms R, C, H, and the oxygen gets reduced to hydrogen. So it is C, completely reduced. In Wolff-Kishner reduction also, complete reduction takes place, and here we can take, say, R, O, R dash. So first of all, here we will form hydrazone using hydrazine. This is hydrazine. Using this, first of all, hydrazone is formed. R, C, R dash, double bond, N, NH2. And after that, N2 is taken out, N2 is taken out, and hydrogen is substituted. Okay, this hydrazone is formed in presence of water. Water is also taken, and here we take KOH and ethylene glycol. So two hydrogens get added over here, and this comes out as N2. So it forms R, carbon, R dash, hydrogen, and hydrogen plus N2. So see, it is also completely reduced now. So what is taking place? Complete reduction is taking place. Complete reduction. When ketones are oxidized, they undergo oxidative cleavage. Whereas aldehydes, when oxidized, they form carboxylic acids. We will see how. Oxidation, of ketones and aldehydes. In case of ketones, oxidative cleavage takes place. Cleavage means breaking of bond. Okay, it means breaking of bond. So let us take one example. If R CH2 CO CH2 R dash is made to undergo oxidation by using K2Cr2O7 and H plus, then this molecule will break into two parts. One part will form RCOOH and the other part will form R dash CH2 COOH. So see, the bond is breaking from here. From here the bond is breaking. In case of aldehydes, oxidative cleavage is not required to take place, at all, because there is only one system of aldehyde like this. The other side there is no alkyl group. So it reacts with any oxidizing agent like K2Cr2O7, H plus, heat, we reflux it, so it forms RCOOH. Okay, so oxidation takes place. Now there are two important reactions, aldol condensation and cannizzaro reaction. Today I will be telling you the reaction and then later on I will discuss about its mechanism, because its mechanism will take little longer session because there are many intricacies in that related to usage of catalyst and choice of aldehydes. So as of now, I'll just give the reaction for you to remember and to be aware about it. Here we will discuss about aldol condensation and here we will discuss about cannizzaro reaction. Now, if any aldehyde, say CH3, CH, H, CHO is treated with base. Then it undergoes a condensation reaction such that two molecules of it condense and forms beta hydroxyaldehyde. Now this is called as alpha carbon. The carbon atom number 2 is called as alpha carbon atom. It is alpha carbon atom. This is beta carbon atom. Now when two such molecules undergo condensation reaction, they form beta hydroxy aldehyde or ketone. So since it is aldehyde, so it will form aldehyde. So this aldehyde will be as it is. This is alpha, this is beta, and since there will be 1, 2, 3, 6 carbon atoms, so 3 we have drawn. One, two, three, 4, 5. 1, 2, 3, 4, 5. Now we have to see that this methyl group will go to one of its branch. So we just put here something is alpha beta. At beta position, OH will come. Here one CH3 will be there. One H here. One H here. One CH3 here. One H here. So it is carbon atom number 1, 2, and 3. We name it as alpha beta. So it is forming aldehyde and alcohol. Okay, aldehyde and alcohol both. That is what is called as aldol. It's called as beta hydroxy aldehyde. Now this will become more clear if we see its mechanism. Let us see its mechanism, otherwise our discussion will not be complete. Now what happens? This OH minus ion, it takes out one H plus ion from here. So it forms CH, CH3 and one carbon ion with aldehyde group. This carbon ion attaches to another aldehyde like this. As a result, it forms carbon, hydrogen, CH3, the aldehyde remains like this, CHO, and from here the connection attaches with this carbon. To make it more clear, We can take an example like this, or we can shade it like this. This part is this part. And this carbon is actually this carbon. This aldehyde is this aldehyde. Now, if we write this molecule straight, then it will look like this. If I make this molecule look straight, this will look like this. This CHO can be written like here, CHO 1H CH3 CO minus. Here it could be Na plus, or it could be in equilibrium with H plus also. H and CH2 CH3. So see, this is carbon atom number 1. This one is carbon atom number 2. This one. At carbon atom number 2, that is alpha, nothing is there. At beta, alcohol is there. Carbon atom number 3, that is beta carbon atom, alcohol is there. So see here, alcohol is there, or its sodium salt is there. So it is forming beta hydroxyaldehyde. This is only possible if the aldehyde contains alpha hydrogen. Okay, so this kind of reaction is called as aldol condensation. Now, here we have taken similar aldehydes. Now, this kind of reaction can take place with different aldehydes also. In that case, we'll call it as crossed aldol condensation, and that will not be of synthetic importance because it will not give pure ald, it will give mixture of compounds. Okay, so it is mechanism of aldol condensation. On the contrary, if we take an aldehyde which does not contain alpha hydrogen, then cannizzaro reaction will take place. Here, the aldehyde does not contain any alpha hydrogen atom. In such case, if you give NaOH, then 2 moles of it will react. 1 mole will form alcohol, that is reduced product, and the other molecule will form acid, that is oxidized product. This is reduced product. It is oxidized product. this is a kind of a self oxidation reduction reaction. The same molecule is undergoing oxidation and reduction. Such kind of reaction we call as disproportionation reaction. And it takes place when alpha hydrogen is absent. Okay. Now, how it takes place? It takes place by certain mechanism. We will see that. We can take one more example of such compound where alpha hydrogen is not there. Say if this carbon is attached with all methyl groups and no hydrogen. So there is no alpha hydrogen atom here. So this molecule will undergo cannizzaro reaction. All these we can term as one term called as cannizzaro reaction. So here one molecule will undergo reduction CH3, CH3, CH3. This will be CH2OH, and other molecule will become, these two molecules will react, and one molecule will become acid. So it is reduced product, it is oxidized product, so it is cannizzaro reaction. Now we'll see mechanism of cannizzaro reaction. Let us take benzaldehyde only. We can take any other aldehyde which does not contain alpha hydrogen. I am taking benzaldehyde. When it is treated with base, then positive part goes here, negative part goes here, and forms O minus Na plus, OH and H. Now this molecule reacts with another molecule of benzaldehyde and gives its hydride. I will make the other molecule with different color. Another benzaldehyde molecule. We had taken two molecules here. Now what will happen? Hydride shift will take place. This lone pair of electron will come back to its place. This remains in equilibrium with the solvent. As it comes to its carbon oxygen double bond position, then this hydride breaks and goes and attaches here. So it forms one molecule will form the acid. Now what happens to the Na plus? Na plus remains in equilibrium with the solvent. Plus one molecule becomes alcohol. O minus, Na plus. This remains in equilibrium with solvent, and H was here already, and that black hydrogen. So is it not like C6H5COOH plus C6H5CH2OH? It is forming oxidized product. It is forming reduced product. So this was all about the properties of carbonyl compounds. In our next class, we will see preparation and properties of carboxylic acids.